Quality gates are essential checkpoints in the software development lifecycle that ensure code quality, security, and compliance before moving to the next stage. They act as automated or manual barriers that prevent the progression of code if it doesn't meet predefined criteria. These gates help maintain high standards and reduce the risk of defects, vulnerabilities, and non-compliance issues in the final product. Quality gates are crucial for maintaining the integrity of the software development process. They ensure that only code that meets specific quality standards progresses through the pipeline. This reduces the likelihood of defects and vulnerabilities in the final product, leading to higher customer satisfaction and lower maintenance costs. Additionally, quality gates help in early detection of issues, making them easier and cheaper to fix. There are various types of quality gates, each serving a different purpose. Some common types include code quality gates, security gates, compliance gates, and performance gates. Code quality gates check for coding standards and best practices. Security gates ensure that the code is free from vulnerabilities. Compliance gates verify adherence to regulatory requirements, and performance gates assess the application's performance metrics. Implementing code quality gates involves integrating tools like SonarQube, ESLint, or CheckStyle into the CI/CD pipeline. These tools analyze the code for issues such as code smells, bugs, and vulnerabilities. The results are then compared against predefined thresholds. If the code fails to meet these thresholds, it is blocked from progressing further in the pipeline, ensuring only high-quality code is deployed. Security gates are critical for identifying and mitigating vulnerabilities early in the development process. Tools like OWASP Zap, SNEC, and Veracode can be integrated into the CI/CD pipeline to perform static and dynamic analysis of the code. These tools scan for common security issues such as SQL injection, cross-site scripting, and insecure dependencies. If vulnerabilities are detected, the code is flagged, and developers are required to address the issues before proceeding. Compliance gates ensure that the software adheres to industry regulations and standards such as GDPR, HIPAA, and PCI DSS. These gates can be implemented using tools like Chef Inspec or OpenSCAP, which automate the process of checking for compliance. By integrating these tools into the CI/CD pipeline, organizations can ensure that their software meets all necessary regulatory requirements before it is released. Performance gates assess the application's performance metrics, such as response time, throughput, and resource utilization. Tools like JMeter, Gatling, and New Relic can be used to conduct performance testing. These tools simulate real-world usage scenarios and measure the application's performance. If the application fails to meet the predefined performance criteria, it is flagged for further optimization before it can proceed to the next stage. Governance in quality gates involves setting policies and standards that the code must adhere to before it can progress. This includes defining the criteria for each gate, such as acceptable levels of code coverage, security vulnerabilities, and performance metrics. Governance ensures that all teams follow the same standards, leading to consistent quality across the organization. Tools like Azure Policy and AWS Config can help enforce these policies within the CI/CD pipeline. Automating quality gates is essential for maintaining efficiency and consistency in the CI/CD pipeline. Automation tools like Jenkins, Azure DevOps, and GitLab CI/CD can be used to integrate various quality gate tools and automate the process of checking code against predefined criteria. Automation reduces the risk of human error and ensures that quality checks are performed consistently and reliably at every stage of the pipeline. Implementing quality gates can present several challenges, such as resistance from development teams, the complexity of integrating multiple tools, and the need for continuous monitoring and updating of criteria. Overcoming these challenges requires clear communication of the benefits, thorough planning, and the use of robust tools and frameworks. Training and support for development teams are also crucial to ensure successful implementation. To effectively implement quality gates, follow best practices such as defining clear and measurable criteria, integrating quality gates early in the development process, and continuously monitoring and updating the criteria. Additionally, involve all stakeholders in the process, provide training and support for development teams, and use automation to ensure consistency and efficiency. Regularly review and refine the quality gates to adapt to changing requirements and improve overall effectiveness. Release gates are checkpoints in the release pipeline that ensure the software is ready for deployment. They verify that all necessary quality, security, and compliance checks have been completed and that the software meets the required standards. Release gates help prevent the deployment of faulty or non-compliant software, reducing the risk of issues in the production environment and ensuring a smooth release process. Release gates are crucial for ensuring that only high-quality, secure, and compliant software is deployed to production. They help identify and address issues before deployment, reducing the risk of downtime, security breaches, and non-compliance penalties. Release gates also provide a structured and controlled release process, improving the reliability and predictability of software releases and enhancing overall customer satisfaction. There are various types of release gates, each serving a different purpose. Some common types include manual approval gates, automated testing gates, and deployment readiness gates. Manual approval gates require human intervention to approve the release. Automated testing gates ensure that the software has passed all necessary tests. Deployment readiness gates verify that all prerequisites for deployment, such as infrastructure and configuration, are in place. Manual approval gates involve human intervention to review and approve the release. This can be done using tools like Azure DevOps, Jenkins, or GitLab CI/CD, which provide features for manual approval steps in the release pipeline. Manual approval gates are useful for critical releases where additional scrutiny is required. They allow stakeholders to review the release, verify that all criteria have been met, and approve or reject the release based on their assessment. Automated testing gates ensure that the software has passed all necessary tests before it is released. This includes unit tests, integration tests, functional tests, and performance tests. Tools like Selenium, Junit, and TestNG can be integrated into the CI/CD pipeline to automate the testing process. Automated testing gates provide a reliable and efficient way to verify the quality of the software and ensure that it meets the required standards before deployment. Deployment readiness gates verify that all prerequisites for deployment are in place before the software is released. This includes checking that the necessary infrastructure, configurations, and dependencies are available and correctly set up. Tools like Terraform, Ansible, and Kubernetes can be used to automate the deployment readiness checks. Deployment readiness gates help ensure a smooth and successful deployment by verifying that the environment is ready for the new release. Governance in release gates involves setting policies and standards that the software must adhere to before it can be released. This includes defining the criteria for each gate, such as passing all tests, meeting security and compliance requirements, and obtaining necessary approvals. Governance ensures that all releases follow the same standards, leading to consistent quality and compliance across the organization. Tools like Azure Policy and AWS Config can help enforce these policies within the release pipeline. Automating release gates is essential for maintaining efficiency and consistency in the release pipeline. Automation tools like Jenkins, Azure DevOps, and GitLab CI/CD can be used to integrate various release gate tools and automate the process of checking the software against predefined criteria. Automation reduces the risk of human error and ensures that release checks are performed consistently and reliably at every stage of the pipeline. Implementing release gates can present several challenges, such as resistance from development teams, the complexity of integrating multiple tools, and the need for continuous monitoring and updating of criteria. Overcoming these challenges requires clear communication of the benefits, thorough planning, and the use of robust tools and frameworks. Training and support for development teams are also crucial to ensure successful implementation. To effectively implement release gates, follow best practices such as defining clear and measurable criteria, integrating release gates early in the release process, and continuously monitoring and updating the criteria. Additionally, involve all stakeholders in the process, provide training and support for development teams, and use automation to ensure consistency and efficiency. Regularly review and refine the release gates to adapt to changing requirements and improve overall effectiveness. Consider a case study of a company that successfully implemented quality and release gates in their CI/CD pipeline. The company faced challenges such as resistance from development teams and the complexity of integrating multiple tools. However, by clearly communicating the benefits, providing training and support, and using robust tools and frameworks, they were able to overcome these challenges. The result was a more efficient and reliable release process with higher quality and more secure software. Quality and release gates are essential components of a robust CI/CD pipeline. They ensure that only high-quality, secure, and compliant software is released to production. Implementing these gates requires careful planning, the use of appropriate tools, and continuous monitoring and updating of criteria. By following best practices and overcoming challenges, organizations can achieve a more efficient and reliable release process, leading to higher customer satisfaction and lower maintenance costs.